Okay, good afternoon or good morning, depending where you are in our country. Thank you for joining us from coast to coast. Thank you very much for attending this webinar, that is organized by the Canadian Academy of Engineering as part of our 2022 National Engineering Month in Canada. My name is Claude Lagu. I'm a professor in the Faculty of Engineering at the University of Ottawa, and I'm also a fellow of the Canadian Academy of Engineering, and it's my great pleasure to serve as the moderator for today's event. Before we begin, I want to acknowledge that I'm speaking to you today from Ottawa, which is the traditional unceded territory of the Algonquin Anishinaabe people. We respectfully acknowledge the past and present traditional owners of this territory and their unique role in the life of our region. We pay our respects to their elders, past, present, and emerging. As settlers, we are grateful for the opportunity to live, to work, and to play in this territory. And for the many of you joining from other parts of our beautiful country, I also want to respectfully acknowledge the traditional territories of First People on which you gather today. For the benefit of all of you who may not be familiar with our organization, the Canadian Academy of Engineering is the national institution through which Canada's most distinguished and experienced engineers provide strategic advice on matters of critical importance to Canada. The Academy is an independent, self-governing, and not-for-profit organization that was established back in 1987, the year the Canadian engineering profession officially celebrated its first 100 years of existence. And it's one of the three national academies that make up the Council of Canadian Academies. We have over 800 fellows from across Canada, all of whom have made significant contribution to engineering in Canada in the private, public, and academic sectors. Today, we will be discussing the matter of the Canadian Engineering Grand Challenges with 4 remarkable CAE fellows. So a few etiquette and housekeeping items before we start. First of all, I must mention that the views and opinions that are being expressed here today are those of the speakers and myself, and that they do not necessarily reflect the official policy or position of the Canadian Academy of Engineering. I know that by now, more than 2 years after the beginning of this pandemic, all of us are very familiar with Zoom, Teams, and all these other tools that have allowed us to meet from everywhere on the planet. So during today's webinar, we ask you to keep your microphone muted and also to use the chat function. There will be a Q&A period at the end, and we will do our best to answer as many of your questions as possible today. And finally, for your information, this session is being recorded and will be available on the CAE website. A presentation from the panelists will also be available on the website. So without further ado, let me introduce our first panelist, who is Dr. Kevin Deluzio, a fellow of the Canadian Academy of Engineering, Dean of the Faculty of Engineering and Applied Science at Queen's University in Kingston, Ontario. Kevin is a professor of mechanical and materials engineering and the head of the Human Mobility Research Lab at Queen's. He is a fellow of the Engineering Institute of Canada and also the current chair of Engineering Deans Canada. So during the next 5 minutes, Kevin will introduce us to the Canadian Engineering Grand Challenges. Kevin, the floor is yours.
Okay, now can I share? Okay, can you see? I'm seeing some nods. That means that I can that you can see my screen, which is good. And it's wonderful to be here, everybody. And it's wonderful seeing some familiar faces and names here across the country as I presume look through the screens. Of course, it'd be great to be here in person, but I'm remarking that this is wonderful to be able to do something like this at noon and gather to talk about such an important issue. You know, the idea of grand challenges has been around for, well, at least the past century, and these been used to focus, galvanize, to inspire us. These are high-level aspirations, that reflect broad, complex problems that have deep societal importance, and solutions are imaginable, but the path is unclear. And I think in this group, we'd all agree that engineers play a critical role in solving the world's grand challenges. A few years ago at the EDC, Engineering Deans Canada meeting out in PEI, I think it was in 2017, the idea of creating a series of grand engineering challenges for the Canadian engineering community to work on was presented. This had wide support, and the goal was to make these challenges global, but have a uniquely Canadian context. The Deans wanted to develop Canadian engineering challenges that reflected unique characteristics of our people, our natural landscape, and the challenges we face as Canadians. We focused our attention on the UN SDGs, the UN Sustainable Development Goals, to examine how engineering could contribute to these goals. Now, these goals were adopted by the United Nations member states in 2015, and they represent a bold vision for your future where poverty, inequality, environmental degradation are eradicated, and in its place, sustainability, equity, and abundance are the norms. So we then gathered a couple years later at the University of Guelph in May, where we had 30 people following on from our national meeting to join a brainstorming session to identify how Canadian engineers can address the UN Sustainable Development Goals. So you see here on your right, there's a picture of actually one of the sheets that we used during that brainstorming session, where we basically listed out all of each of these 17 UN SDG goals. And ideas were documented. If you can read some of the ideas, they were ideas about engineering projects and things we could do as engineers to address these challenges. We put the sheets up around the room and we really reflected, voted, talked about which are the most important ones that the Canadian engineering community could focus on collectively. So we prioritized areas that could be done where we could actually have some action in a real meaningful way in a short term. And then we took these ideas, they were coalesced, we poured through them for a while and developed from them 6 areas that were rooted in the UN SDGs that became the Canadian Engineering Grand Challenges. And here they are here: resilient infrastructure, affordable and sustainable energy, safe water in our communities, safe and sustainable cities, sustainable industrialization, and inclusive STEM education. Each grand challenge that we identified is a very broad but discrete concept where engineering expertise and leadership can be brought to bear on these ideas. We then engage with researchers and thought leaders across the country to articulate these challenges in terms of what's the current state, what are the particular challenges we're facing, and what are the benefits to Canada. And you can see the details of each of these on the Engineering Deans Canada website, where the document is there. And there is a brief on each one of these 6 challenges that is available both in French and English. We also engaged with students through the Canadian Federation of Engineering Society, students, on the learning outcomes. How will a student be a different student because they've engaged and are working on these grand challenges? We're also very pleased, we're here with the Canadian Academy of Engineering to have them endorse these challenges along with the Canadian Federation of Engineering Students. And it's interesting to see how they map on the original 17 SDGs. So you can see, and here's the mapping of each of each row is an individual challenge, and then we've populated with the icons that represent the UN SDGs. And you can see, for example, that some are very much more prominent than others. 3 of the goals, goal 3, good health and well-being, goal 10, reduced inequalities, goal 13, climate action, linked to all 6 grand challenges. Now, as engineering deans, we see these as an opportunity for our engineering students to engage with these large, complex, and socially motivated problems that require an understanding of multiple perspectives and disciplines. You'll hear more about the impact on education and research from my colleagues, but these grand challenges are really a call to action for our engineering community in Canada. And to move us forward to this vision, our world really needs creative problem solvers, entrepreneurs, curious thinkers, leaders such as we have with us today, who want to change the world, but they need to solve these problems not in isolation, but by working with the very people that are impacted by these challenges and across disciplines. I know you'll enjoy the other presentations today, and we're really thankful to have you here to discuss these grand challenges for the engineering community.
Thank you very much for setting the stage, Kevin. We now welcome Dr. Jim Nicell, who's also a fellow of the Canadian Academy of Engineering, Dean of the Faculty of Engineering at McGill University in Montreal, Quebec. Jim is a chemical engineer who specializes in the field of environmental engineering with a particular interest in the mitigation of industrial and municipal pollutants and their replacement through green chemical that are renewably sourced. Jim is the past chair of Engineering Deans Canada. And as Kevin already indicated, Jim will now further explain some of the implications of the Canadian Engineering Grand Challenges on education. So Jim.
Hello, good afternoon, everybody. Thank you, Claude, as well for inviting me to make this presentation, and Kevin for that great introduction of the Canadian Engineering Grand Challenges. Now the question is, how do we put them into action? And I've been asked to address the key issue, which is, what are the implications of adopting these Canadian Engineering Grand Challenges in the context of engineering education? Just to give you a sense of what we're talking about, further to our meetings that we use to, amongst all the different institutions, to establish what the Canadian Engineering Grand Challenges were, we then had a subsequent sessions to actually identify what student competencies might we expect to derive from education that would be required to support the grand challenges of addressing these really important issues. Some very simple, simply said, student competencies that we identified are listed on the slide, as you can see here. There's a lot more behind each of these very simple statements, and I'll go through them very, very briefly. So the first is the ability to design and create, but it means about adopting a very different approach that is required to address the complex problems of the Canadian Engineering Grand Challenges that require deep engagement with stakeholders, but not only at the outset when we're actually defining the problem itself, but also throughout the entire creative and design process, and both during and after implementation. Essentially, what we're asking is that the design process incorporate aspects of active listening, mindful conversation, and embracing the vulnerability of not only ourselves, but our populations, which are all crucial to success. The second one is the ability to integrate and solve. Now, appropriate and effective to grand challenges can only be achieved by integrating multiple points of view and knowledge from a array of disciplines, not just the ones that engineers bring to bear, but also many other disciplines who have a lot to say about these challenges. We really need systems thinking at a broad level and the balancing of very competing constraints that are both technical and social. Also addressing this, we also have to deal with the careful mitigation of risks. When we're undertaking our very complicated projects, there can be difficult outcomes that have to be dealt with. And of course, we also have to have a deep commitment to understand and take responsibility for the intended and potential unintended effects of our work. The third is the value of business and innovation. Essentially, grand challenges require the adoption of viable, socially responsible models that put the stakeholders first to develop successful and sustainable solutions that work over the long term and deliver value both to the shareholders and the stakeholders. This would really set the agenda for actually making really wonderful opportunities out of the crises that are in front of us for the development of the long-term benefit of society. The fourth is the practice of being multicultural and diverse. Essentially, we're asking for respectful and open engagement with cultural differences that require an openness, a curiosity, and ability to listen. Of course, none of this is really easy or comfortable, but it leads to essential understanding, and if done correctly, will lead to meaningful progress toward the solutions to these grand challenges. The fifth is a commitment to community, which is serving people and community through more collaborative practice. This is an essential vision of what the Canadian Engineering Grand Challenge project is. It requires a deep social consciousness and a motivation to address social problems, but often gained through community service learning. And then finally, championing environmental stewardship, which is essentially about identifying ways in which engineers and engineering projects can contribute to a healthy and sustainable environment in concert with sustainable long-term employment and economic prosperity. This is easier said than done. How do we actually execute on this? Well, from a conceptual framework, I just lay it out here. What I see as, in a sense, the problem that we have to address these complex problems. I would argue that when we're dealing with problems as engineers, we have a natural tendency to focus on purely technical solutions to various problems. I would argue that if you look at the left-hand side of the screen, that we need to move up the range of the complexity of the types of problems that we're ready to address. And this could include all the way up to the wicked problems, as they're called, which involve no clear path forward, no clear outcomes, in fact, with solutions that may actually have to adjust over time. But in order to address these really complex problems at the upper end, perhaps we need to let go of some of the simpler issues of technology and leave it to others who are already encroaching, if you want, in the area of engineering on purely technical matters. But if we're going to do this properly, we also need to look at how engineers actually solve the problems. And we are all used to solving problems through the design, creation, and application of technologies, but we're also used to doing it under constraints. My argument here is that we need to broaden the range of constraints that we're ready to engage with, just to make sure that the solutions that we propose are actually meaningful. And this means moving beyond cost, time, quality, functionality, safety, financial viability, all the way up to economics and social environmental factors, life cycle considerations, diversity of cultural needs, views, etc. So we have to engage and be willing to engage with a more complex set of constraints. We also need to mobilize a broader knowledge base instead of tools. Now, the issue for me here when it comes to engineering education is that there's so many tools already at our disposal, but there are many that have been under development and continue to develop over time. You know, for example, we need to think about life cycle and socioeconomic analyses. We talk a lot about the triple bottom line when it comes to businesses, but look at the developments in genomics, CRISPR technology, nanotechnology, the new advances in renewable energy, advanced materials, additive manufacturing, blockchain, the range of tools goes on and on. So the question there is, how do we prepare our students to actually mobilize this knowledge base and tools? And if we do it properly, moving up the complexity chain in terms of the problems we address, properly addressing the constraints and mobilizing knowledge base and tools, presumably we'll be able to come up with a different set of solutions that are more appropriate to the grand challenges that are ahead. The problem, though, we have in an education perspective is how the heck do we do this? Now, one approach might be is, oh, we just keep adding more and more courses into our students' programs. So, you know, symbolically represented by that Swiss Army knife, which is just crazy. So many tools as part of the education make our educational process guilty and actually quite useless. The other issue is, as there's a tendency for us to try to keep our educational programs, let's say to the standard 4 years, is to jam more and more material into the heads of our student in the same time period, essentially like trying to close that suitcase in an impossible way, trying to get our students out in a reasonable time frame. That's one potential model that we could choose. Or the alternative is to actually look at the more elegant solution, the tools shown at the right, which is more to identify how do we create a very clear and focused tool that can be adapted to the changing tools that are in front of us over time. Those tools will change inevitably, need to be switched out, and new ones mobilized. And so then the question is, how do we actually then adapt to a different type of education that creates an elegant set of people who have an elegant set of tools at their disposal to solve these complex problems? And if we go further than that, I think we also need to look at the issue of interdisciplinarity. These complex challenges in front of us in terms of the grand challenges they could require somebody to have a phenomenal tool set available to them, a knowledge base that's incredible. So what we end up with in education is often a really terrible debate over whether we should, let's say when we think of it from a T-shaped education perspective, we could ask our people to go really, really deep in terms of specialization, which is the first T that you can see on the left-hand side of the screen, with a breadth at the top that kind of engages the social issues as an example. Some people say, no, 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 that's not enough. You have to get more people with more social consciousness, a wider array of skills, let's say, to adapt to social realities, business, etc. So they would argue go really broad and not so deep. And you end up with this crazy dialogue back and forth about what's the best way forward. And some people say, well, the solution to that is just go both broad and deep. And so you create a massive T, which effectively means if you want to do this, you have to allow our students to take their courses, but probably over an 8-year period. So create everybody who's a jack of all trades. I would argue that this is not going to work when it comes to the Canadian and Grand Challenges. We as engineers are already used to working as teams. That's what we always say as part of our educational programs. But why does every member of the team have to be the same? So I would argue that the approach is not the above, but the below model, which is forming teams of people, each which have a core outlined in blue, of which is a common engineering curricula at the core, but allowing some people based on their interests and their capacity to either go deeper. We still need people who go deeply into the highly technical issues, but also allow for another group of people who can go broad. And if you put these people together, we actually create a complementary set of skills with engineers who speak the same language, understand the context of the problem they're working with, understand the nature of the tools that are out there, but mobilizing differently as a team. In practice, what this means is actually changing the way we do education to focus more broadly on problem-based or project-based learning. Open-ended problems that have a very strong focus on dealing with complex issues and gradually bringing students to a higher and higher comfort level in dealing with these open-ended issues with broader constraints and adapting to different sets of tools. A key part of this, though, is preparing them to actually work across disciplines. And here I don't just mean a mechanical engineer working with a civil engineer. I actually mean working outside the boundaries of our discipline. And we're starting to see certain initiatives, let's say in capstone design courses in many institutions, where we're bringing in students from the humanities to work in full partnership with us on our projects. And a key part of this in having cross-disciplinary teamwork is to recognize the value of other perspectives in our work, which broadens our EDI focus, more equity, diversity, inclusivity in the approach that we use, which prepares us better to focus on broader range of stakeholders. When it comes to our programs itself, I'll just say our Bachelor of Engineering programs, Bachelor of Applied Science, whatever it may be, the question is reduce down to what the core essentials are of all our programs, but allow flexibility for students who can actually adapt according to their interests. Some may want to have a stronger, deeper technical focus. Some may want to have a deeper focus on business and entrepreneurship as an example. Other may be more philosophical or even political or policy orientations. Similarly, in your Masters of Engineering programs, we've often think of them as just an opportunity to really deepen the expertise of our people. There's a question here that I have about why could master's programs not also be equivalently used to broaden the capacity of our students? So think of a civil engineer who takes more courses at the graduate level in civil engineering, but couples them, let's say, with a policy perspective that builds upon the foundation that they got in their undergraduate program. And then finally, PhD programs, and probably don't want to go into any of that here, but I have a real issue with the fact that PhD programs are heavily, heavily focused on hyper-specialization. And I think that there's a huge opportunity between our different disciplines for some students who are not necessarily heading toward an academic career to actually fill an opportunity there, crossing various disciplines and mobilizing their knowledge in a very deep and effective way. And I think a key to all of this is collaboration within the university across faculties to break the model of our learning at our bachelor's, master's, and PhD programs, but also to mobilize the capacity across the country through interinstitutional collaboration, of which I would argue the Canadian Engineering Grand Challenges is just one great example of how that can be achieved. Thanks very much.
Thank you very much, Jim. Our third panelist is Dr. Mary Wells, Fellow of the Canadian Academy of Engineering and also Dean of the Faculty of Engineering at the University of Waterloo in Waterloo, Ontario. Mary is a materials engineer who researches advanced metallic alloy for use in the transportation sector. She chaired the Ontario Network of Women in Engineering between 2013 and 2018. And she also served as Dean of the College of Engineering and Physical Sciences at the University of Guelph before assuming her current responsibilities in Waterloo. Mary will follow up with regards to what Jim indicated about education. Mary will share some insight on the implication of the Canadian Engineering Grand Challenges on research.
Thank you so much, Claude, for that lovely introduction, and welcome everybody. It's just such a pleasure to be here today to really talk about a topic that I think everybody can really relate to in terms of its importance at this moment in time. So I really just wanted to touch on what we do around engineering research and how it can support the Canadian engineering grand challenges. And when we think about the Canadian research community, it is one of the backbones of these Canadian engineering grand challenges. And really, it's the commitment of research to finding evidence-based answers that becomes a driving force for creating advances in health and well-being of people in Canada and around the world, poverty reduction, life expectancy, changes related to climate action, and things like this. So it is a key part of what we do at universities. And something that I just wanted to touch on, and it really will go back to many of the aspects some of my colleagues have already talked about in terms of when we think about these large societal problems, we can't do it in isolation of some of the other disciplines. Okay. So before we start, I just wanted to talk a little bit about science versus engineering, and I'm assuming most of the people on the call are engineers, but the reason I bring it up is that really as researchers, we both advance scientific knowledge, I would say, but also engineering knowledge. And I was at a conference once and somebody spoke about this quite eloquently, and they really simplified it like this, that often in scientific research, researchers are given dollars and the outcome is ideas. And these are new ideas and new knowledge that can help to allow us to understand the disciplines better. Engineering research, on the other hand, often takes ideas and the translation is back into dollars in terms of the development of new enterprises, new knowledge that can then be taken and applied back into industry to help advance industry. So it's a little bit of a difference in terms of how we approach it from a scientific perspective versus an engineering perspective. But really, as researchers, we do hope to advance knowledge in both of these domains, both scientifically as well as from an engineering perspective. To start the presentation, I really just thought I'd think of a very global perspective. And this was a research publication that was produced in 2020. And the title of it really was to look at the power of data to advance the Sustainable Development Goals, and really mapping some of the research that was being done on a global basis to the Sustainable Development Goals. So it was published by Elsevier, and they'd really created a series of search strings so that they could then look at each of the publications in different knowledge domains that had been developed and see how they could then map it back to the Sustainable Development Goals. And so I've just chosen a couple to start this conversation. The first one being good health and well-being. And when we think about the period of time between 2015 to 2019, there were over 4 million articles that were produced, research articles that were produced related to specific Sustainable Development Goals. And by far, the largest one was in the third Sustainable Development Goal, good health and well-being, with a little over 3 million articles that were published related to this. Now, on the just below that, on the left-hand side, you can see sort of a series of words here. This is just looking at kind of a word cloud where they looked at some of the words that were extracted from those publications. And clearly the words that are bigger are some of those ones that appeared more frequently. So you get a sense of where that research is going. The circle on the right-hand side is an interesting way to show the data. And really the circle is a knowledge circle. So it does try and represent our different domains or disciplines of knowledge, ranging from computer science, mathematics, through to all the physical sciences, through to the engineering and applied sciences, through to the arts and humanities, etc. And really the reason I thought this was such a nice way to display the research is really how the knowledge intersects with each other and how all of the disciplines can contribute to knowledge in these areas. Clearly for this one, we see that the majority in the red circles here are in the area of medicine, veterinary, pharmacy, but we also see that engineering over here, sort of in the blue zones, are also contributing to good health and well-being. And that's not something that might have happened a decade ago as prominently as it is starting to happen now in terms of the use of technology and engineering knowledge to help advance good health and well-being. The other example I want to show you, just one more, is for affordable and clean energy. And just to show you the contrast now in terms of the disciplines that are really helping to move this Sustainable Development Goal forward. And clearly in this one, we see the dominance that engineering will play alongside materials, some of the physics, some of the mathematics that's being used, as well as the environmental over on this this part of the circle, let's say. So it does give us a good perspective, firstly, of the knowledge domains that are helping contribute to the research that's going on in these areas. But also, I really wanted to drive home the point that there is no one discipline that's helping to advance these, because they're so interdisciplinary, and that it's so important for all of us to come together to do that. So let's get more specifically focused on what's happening in Canada and how our universities are helping to contribute to the UN Sustainable Development Goals. And so what we did, and I must give a shout out to two of my colleagues, Wendy de Gomez, who is a research analyst in our engineering research office at the University of Waterloo, and Mahima Patel, who's an engineering student in computer engineering, who we hired last summer to help just look at some of the metrics from a Canadian perspective. And so what they did is they looked at kind of the 17 top research universities in Canada, looked at the faculties of engineering and identified all the professors and got their IDs and were able to create kind of a database of all the research publications that they had done between 2014 to 2018. They then took this information and used those search strings that had been identified by Elsevier around the UN Sustainable Development Goals to really give us a quantitative sense of what research we are doing in Canada, engineering research at our faculties of engineering, that are really helping to advance these Sustainable Development Goals. So this graph you see right here is a graph that they were able to generate based on this data, and it really just shows the engineering publication share of all the Canadian publications between 2014 and 2018, and what fraction of that share of all the Canadian engineering publications that were published during that time was related to some of the different UN Sustainable Development Goals. So on the x-axis, we have the percent of the publication share, and then on the y-axis, we have some of those UN Sustainable Development Goals. And clearly you see that firstly, engineering research contributes to many, many of the UN Sustainable Development Goals. In fact, almost all of them. And there may be some that are surprising to us, things like peace, justice, and strong institutions. About 4% of all the publications that were written in Canada, research publications, were done by engineering faculty members. You can see that clearly there are a couple of areas that we are leaders in. Maybe they are the usual suspects. And by far the most important one we have contributed to is in the area of affordable and clean energy. And in that domain, about 40% of the publications that were published were done by engineering researchers. And we've really only captured the engineering research that's being done at the universities. If we wanted to do a more fulsome approach, we could take and integrate some of the other researchers at our national research labs and other research places that are contributing. The other ones that really we contribute significantly were areas such as clean water and sanitation, where we're close to 28% of all the publications, industry, innovation, and infrastructure, just over 20%, as well as sustainable cities and communities. So these are all areas that we are focused in, that we are making a very, very significant contribution to. Finally, this is my last slide, but it just gives a perspective from coast to coast as to the ways we are contributing, and just a sense of, the number of engineering faculty members that are involved in research related to these UN Sustainable Development Goals, the number of publications they're engaged in, as well as the Sustainable Development Goals that have the highest average impact factor. So again, ranging from BC, where we have over 300 faculty members that are engaged in research that's leading to publications in this area, over 1,500 publications. And really, we can see clearly across the country that the affordable and clean energy really stands out throughout the entire country. We see in some regions, like Saskatchewan, good health and well-being is a strength for them in terms of some of the research they're doing. And then I guess no surprise, perhaps, that in other areas, things related to life on land and things like that. So it just gives us a really nice perspective of how all of our universities are contributing to help advance both the UN Sustainable Development Goals, but now as we position it to look at the Canadian Engineering Grand Challenges, how they're also advancing those objectives as well. So thank you very much, Claude. I think I'll stop right there.
Yep. Thank you very much, Mary, for a very enlightening presentation. And finally, our fourth panelist is Mr. Bruce Taylor, Fellow of the Canadian Academy of Engineering and the founder of EnviroStewart. EnviroStewart is Best for the World Classified B Corporation It's also recipient of a Global Compact Canada Sustainable Development Goal Award, and it's the only Canadian company who have won a Global Sustainable Development Goal Award. Enviro Stewart does sustainability engineering work for a number of companies and other organizations in our country, as well as abroad, and the company has won numerous national awards. Bruce also founded the Safe Water Social Venture Project in South Sudan that has won an International Global Award and was featured in the Be the Change magazine, as well as in TEDx Talk. And speaking TEDx Talk, we'll now watch a short video that showcases Bruce as well as the work of his company.
Bruce Taylor of the Enviro Stewards understands the value of food better than anyone on the planet. Some folks call him the David Suzuki of food waste, in that he's an incredible educator who's also doing the work on the ground. He's maybe more obsessed with dumpsters than the average person, but that's what we love about him.
Almost all the approaches are, how do we destroy this food more efficiently? With a composter or a digester, you lose all that value. Even if you divert 100% from landfill, you still lose almost all the economic, all the social, all the environmental. The only way to not do that is to prevent the loss in the first place. And so we've proven that it can actually be accomplished. We went into 50 factories in a row, and we found $240,000 per factory per year of food that didn't have to be wasted. For perspective, if you put a grocery bag beside the CN Tower, another one, you'd get to London before you ran out of grocery bags. Maple Leaf Foods is the first large food company in the world to be carbon neutral. One of the nice things about it is it then shows, like, there's so many companies now saying, oh, we're going to be carbon neutral by 2030 and 2040, and how are we actually going to do it? It's really nice to have somebody, hey, we're already there. So it's possible. So once you have some people showing that it's possible, then it makes it easier for the rest. In Maple Leaf's case, they actually had us go into all their facilities across Canada and find practical, affordable ways to reduce the loss in the first place. I guess what we find is a lot of people think that their dumpster is their cheapest bill in their factory. You know, they haul it away pretty cheap. How much did it cost you to buy what's in that dumpster? What was it worth just before you lost it? A better way to look at it is, this is food. How do we prevent it from being lost in the first place?
Okay.
Yeah. So Bruce will discuss the implication of our Canadian Engineering Grand Challenges on industry and also on the practice of professional engineering. And just before I ask him to begin his remarks, just want to remind you, as I indicated on the chat, that we are very interested in your feedback, the feedback from the participants. So if you have questions for our panelists on any of the topics that have been discussed so far, as well as those that Bruce will be discussing in a few minutes, just don't hesitate to post them in the chat, and we'll make sure that we address them once we're done with the remarks from our panelists. So Bruce, the floor is yours.
Thank you, Claude. And thank you for this opportunity. That video clip was from a documentary series, a 4-part series on food waste in Canada called Half Full. It's available for free on the internet. It was put out by Loblaws, I think. And so if you're interested in kind of what the Canadian community is doing in that, that's just a little excerpt from it. So for my talk, what I want to do is I want to go through, as an engineer, I'm a chemical engineer, how does that relate to the challenges and the SDGs? And from my perspective, it's more the approach of how you do things. So as an engineer, you don't always get to choose what projects you're working on, but you get to choose how you're going to do it. And how you do it actually affects a lot of the impact, positive or negative. Plus, you have an opportunity to, focus, I'm going to go after this type of project also. So that's kind of where I'm going to get at. I'm going to use quite a number of real life case studies from it. And then I'm going to get into the social justice aspect of sustainability at the end. EnviroSters itself, we're a small engineering company, 22 years old, just north of Waterloo. We're about 18 people. We say that we cultivate resilient business and improve lives. And you saw some of those aspects before. I'd really encourage you to look into that B Corp movement. These are companies that are set up to accomplish an environmental or social benefit. And so ones you've heard of are Patagonia, Method, 7th Generation. So it's a really nice way of formalizing your environmental social governance. So I want to talk about approach. So Here's a company in London, Ontario. They distill solvents for the auto sector. So they get the paint solvent from Ford, Chrysler, Toyota, Honda. They distill it and sell it back to them, right? And so you see that wall fan there in that circle. And so basically it's blowing air out the wall. And when you talk to them, you say, well, why do we have this? Well, it's not safe to breathe in here. So I took our meter and oh, there's 3,000 parts per million of volatiles coming from that one tank. And that's still bottom tank. So this is the stuff that didn't distill. So if we only did energy, electrical energy efficiency, we would get them a better motor for that fan. If we did thermal, we would get them a heat exchanger. We get 60% of that heat back that's blowing out of the factory. But instead what we did is we sealed that tank and we put it through a condenser, condensed the solvent as solvent. Now, it's the same problem we're solving, right? Is saving their energy. It's just that by not putting the toxics in the air, you actually save more energy than you can save by doing an energy study. And you don't have the worker exposure, you don't have the toxic emissions, you reduce the supply chain footprint because you need less petroleum to make the same amount of solvent, right? If you're not wasting it. And so this is kind of, the nuances of how you go about your work. You can either positively or negatively affect these grand challenges and each of the 17 sustainable development goals. In our own case, so we've reduced our footprint 78% per employee. We're in a 100-year-old building, right? So different things we've done, that's a living wall. We tied it. A lot of people have living walls. We actually tied it to our rooftop unit. So it sucks all the air in our office through there. The plants take out the oxygen or the CO2, put in oxygen. 97% of the year, we take no air. A normal office would take 10% fresh air all day long, all year, heat it up all winter, cool it down in summer. We only do that 3% of the year. We don't even buy water for that thing. We've used rainwater for the last 5 years on that wall, which makes the plants healthier than all the other installations from this vendor. They send people to look at our wall because it's better. And part of the reason better is only getting rainwater, which is actually better quality for plants than city water, right? So just kind of different nuances on the right there. We've started a blue roof on our office last June, and we're going to start it up again this April. Literally, we're storing the first 2 inches of every rainfall on our roof, which that's most storms. #1 insurance claim in Canada, flooding. It's doubled in the last decade due to climate change. We don't even put it down the drain, right? We just leave it on there. We let it evaporate, which cools our office. And we got water to run our toilets and our neighbor's toilet and all that kind of stuff, right? So, you need these creative type of solutions. And you can see each of these slides, you got kind of the purple engineering grand challenges. You'll see that each one affects kind of multiple. But our real impact isn't our footprint. It's what we call our handprint, the work of your hands. You got an iron ring on your hand there. So in our case, we're now down to 4 tons of greenhouse gas from our operations. But our work avoids 120,000 tons a year at our customers. So we're actually avoiding 30,000 tons per ton, which is a better metric than how do we get rid of this remaining 4 tons we've got, which we are chipping away at, and that blue roof will do it kind of thing. So that video, the Maple Leaf example, so they're the first large food company in the world to be carbon neutral. Everybody's saying, oh, 2030, 2040, 2050, sometime after the last ice melts, we're going to be carbon neutral, right? And nobody knows how to get there. And if you do, it's going to cost you a lot of money. Well, we just proved you can do it and be more profitable. So we went into 35 factories. We modified the factories to use less energy, water, lose less food. That generated more than enough savings to pay for their entire footprint. So all their packaging, all their animal feed, all their tractor fuel, fertilizer, pesticides, whatnot, from those savings, and have millions of dollars left over. So it's possible. And it's, again, the approach. If we just started with offsets, then we could cost them multi-million dollars every year, right? Or if you just start with renewables, same thing. So just, again, the way you're going about it. On the food waste, you saw that in the article where 1/3 of the food on the planet is wasted right now. If it was a country, it would be the 3rd largest greenhouse gas emitter after China and USA, is just wasted food. But the 2nd largest consumer of potable water on the planet is growing food that we waste. And 49 billion in Canada, 1 trillion worldwide. And again, everybody's trying to divert it from the landfill with digesters. As engineers, it's very exciting to build a digester, but you still lose all that value. You don't get that food back, right? So then here's an example. So Campbell Soup in Toronto, we did a kind of a process integration, which is a nice kind of engineering kind of project where you're doing a very deep dive on all the water, all the energy sources and sinks in the whole factory, and you do a matchmaking game. That's that chart on the right, that blue and red sources and sinks of heat, and you do a matchmaking. So putting that together, you found 1.6 million a year of additional profit. We did a food waste. We found 700,000 a year of food that didn't have to be wasted. Now that food was going to a waste energy plant, But by not wasting the food, it's actually 4,000 tons less greenhouse gas than growing the food and turning it into energy. And so the source reduction is always kind of paramount. So as a chemical engineer, this is kind of right at home, is how do you build a wastewater treatment plant for this wine factory? So Jackson Triggs in BC, they're using 85% of the town's capacity. The town says, we can't grow our town, you have to treat your water, which is a normal challenge for wastewater. But instead of building the treatment plant, we cut the water in half. And we cut the amount of wine they're losing by 2/3. So then we built them a high rate anaerobic system, but half as big, half as expensive, half the footprint. It's got a biofilter for the odors, and we're making methane and burning them again, which, you know, is common engineering things, but it's half as big. But unfortunately, we make half as much money to do that because you get 10% of whatever you design. If you design it half as big, half as expensive, you get half as much. So there's kind of structural barriers that we could get into later if you want, of kind of how do we promote things that are actually good in the long term. Water, so we did York region, with just north of Toronto. We did 60 factories, found 1/3 of the water per factory that didn't have to be used in the first place. Or we did the space shuttle in Florida. We did 100% water recycling for the booster rockets. Winery in Southbrook Winery in Niagara-on-the-Lake. They just had an energy audit done just before us. And they said, okay, your next 5% is 20-year payback. New LED lights, new chillers. Well, that report could be written for 100 wineries, right? We got right into the weeds where, okay, why do you have this big ventilation system? Well, the wine's got to be plus or minus 17 degrees, plus or minus 1 degree. Okay, this is wine or the water or the air? The wine. So we put a thermocouple in a jug, put another one in the air beside it. Turn the system down 70%. It never moved. We left it 70% down, right? But the trouble is people are buying energy audits. If you buy an energy audit, the cheapest one to buy is the one that was already written before they even came to your factory, right? But that's actually the most expensive one because they put in those solar panels, 7-year payback solar panels, because they thought it was a 20-year payback. But by not using the energy, is a 4-month payback, right? So it's actually more expensive to have a crummy audit than a good one, because it also saved those 2 rows of vineyard from getting covered with solar panels, because he literally canceled 1/3 of them because he didn't need the energy anymore, which again gets into many challenges kind of thing, or as far as grand challenge, you know, biodiversity and that, not if you're making better use of your land, that kind of thing, or climate justice. So in Canada, we're about 16 tons per capita of greenhouse gas. In South Sudan, where we work, 0.4 tons. So we have created the climate crisis in the developing countries. And it disproportionately affects those in developing countries, right? They're getting the floods. They don't have the irrigation systems to accommodate droughts, these kinds of things. So they're getting the impacts of what we created. But even worse than that, the solutions we're designing to the climate change are designed to benefit us in the developed country and limit the benefit to the people in developing. For example, many frameworks say your carbon credits have to come from Canada, because we all know we only got, you know, 1 atmosphere on the planet. Why does it matter where you put the carbon in the air? It's just kind of self-serving. Or poison pill clauses. You know, oh, your treatment system in South Sudan has to have 0, you know, 95% isn't good enough. You need 0, you know, so people get no treatment at all because it's not, you know, something that they can't afford. Or ignoring suppressed demand. It's assuming, okay, 0.4 tons a year, that's great. You should always do 0.4 tons per year. You cannot boil your water. You cannot develop your economy. And so as engineers, you know, we have something to say in how these programs are structured so that you get the equity, right? And so love to talk about that sometime too. Again, just what is poverty? If you ask a Canadian engineer what poverty is, they're going to say, well, it's a lack of money or lack of stuff. So obviously the answer to poverty is money and stuff. If you ask somebody who's actually in poverty, they're going to get an answer like, I feel shame, I'm humiliated, I have no power to change my circumstances, we feel like garbage. None of those things are helped with free money and stuff. In fact, they're hurt by free money and stuff. And so we're trying to solve the wrong problem. And so if you want, we have a UW TED talk on that. It's just called Better Than Charity. It's on YouTube or the TED channel. But, you know, if I tell you 1 billion people don't have safe water, you can say, oh, we should start drilling wells. Well, half the wells in Africa do not work after 1 year because everybody wants to pay for the well driller. They don't want to pay for the organization to maintain the well. All wells break after 1 year, even the ones here. right? They need moving parts. They need somebody knowing how to do it. They need the parts available. If you're not going to put in the system, don't even bother putting in the hole in the ground. It's just a hole in the ground after 1 year. And even the water coming out of it, we tested every well in Kajukeji County, South Sudan. 72% of the boreholes had E. coli coming out of the well. Yes, it looks nice in the picture, but are you really solving the problem? In fact, that's the bottom right. That's the most probable number biology test. So I tested on our toilet in our office. 1 out of 100 of those cells turned blue. I tested the borehole water in Jerusalem, South Sudan, 100. So it's actually 800 times safer to drink the water in my toilet than the water coming out of that well. And so we need to think about things when we design our solutions. So the way we go about it is thinking about, the root cause of poverty is we first do a market. So all these tools are available for free if you want online. Just go to safewattersocialventures.com and how to do a market assessment, how to do a business plan, how to build these filters step by step with videos, how to run a business, how to sell these things. I'm drinking water for free. Why would I buy it? Well, is it really free if you get sick? The average family there saves $1,000 over the 25 life of the filter compared to their medical costs. Again, half the patients in the hospital are there because of bad water. One of the best things you can do in health is just give people safe water in the first place. You cut the caseload in half in the hospital, right? And so this is just some of the flavor of what we're at. And so love to throw it open for questions on research, on education, or on my work with industry. And I'll throw it back.
Thank you very much, Bruce, for a very interesting presentation and comments. So I'm very happy to see that a lot of people have responded to our invitation to basically submit question to our participants. So I'll try to basically do justice to everyone. And I'll go back up the list to the first question we got. And I guess that would be a question, somewhat challenging question for, I think, our 3 deans who were very closely involved with the development of the Canadian Engineering Grand Challenges. So the question is that what would justify the idea that the best interests of Canadian citizens, which are basically, we would assume that our engineering grand challenges in Canada are meant basically to serve the best interests of our country, so that those best interests are aligned with the policies that have been drafted outside Canada. And I would assume that this refers to the United Nations Development Goals, Sustainable Development Goals. So I don't know, between Kevin, Jim, and Mary, who would like to take this on?
I guess I'll just jump in quickly. It is a really challenging question. So one thing I will say is that if you're working on a grand challenge per se, you need to have, as we mentioned earlier, kind of a broader lens through which you're actually looking at the problems that you're trying to solve. So I would include there potential repercussions that flow outside of our own country. So, one example might be that one way that we could make our greenhouse gas emissions potentially look lower is by offloading somehow through, let's say, trade, whatever it may be, our emissions on another area of the world. And so we look good, but it is to the detriment of another country. So I think if we take a broader view on these initiatives to kind of draw the boundary much wider than we typically do in engineering, we will try to make sure that the solution we might propose in a Canadian context is more broadly around the world. The other thing I just want to express here is that these grand challenges, when they were conceived originally, I think it's fair to say were conceived as something we could do in our own backyard to contribute through engineering to solving problems in a Canadian context. But that doesn't mean that the skill sets learned through the very process of addressing these can't be translated to other areas of the world. So we don't mean to define our Canadian engineering grand challenges as solutions to all the problems around the world in that context, but more to use it as an exercise if you want to work together to change our approach to research or our approach to education, to give people the skill set so that when they go somewhere else in their own context, they know how to act when they're in a very different context using the skill sets they've learned in Canadian education research activities.
I might just add too, I think I really appreciate what Jim said about, some of the motivation, and it was really driven in part by, what we do as educators is really educating the next generation of engineers. And, for so long, engineers have been known as problem solvers. And if you talk to engineers, they say, well, I'm a problem solver. But we really want our engineering students and our engineering profession to go beyond thinking of themselves as problem solvers to also helping define what the problems are that should be solved. Instead of in some back room somewhere, somebody else defines a problem, says, okay, engineers, go and work on it. We think of technical solutions, right? Where they haven't traditionally been as engaged in that or seen themselves in that way. And that really speaks to leadership in many of these things. And by giving them these kinds of opportunities, our hope and our desire is that they will become the next generation of leaders to help define the problems, to help engage in those conversations, to amplify their voices in terms of the role that engineers do play in society, and to allow other people that might not traditionally see themselves as engineer, see where they could fit in and how their voices and their intellect can help contribute to these opportunities.
Thank you very much. We have a few questions that relate to Mary's presentation about the engineering research publication as they relate to the Sustainable Development Goals, and including one that is very specific, and probably Mary can respond to it directly. But there's an interesting one about what question that basically is, what are the gaps between the percentage of publication between 2014-18 versus the present grand challenges, and are there any explanation as to why there are gaps and how these gaps can be closed or will be closed in the future? Because I think going back to your slide, Mary, we saw that there was a lot of Canadian engineering researchers who were working on some limited number of the Sustainable Development Goals, while others were much less covered. So how do you see that evolving in the future?
Well, and again, it doesn't mean that these other areas or UN Sustainable Development Goals aren't being covered. It just means that they're not being covered as much, or engineers aren't participating as much in the research. Now, engineers contribute significantly to good health and well-being, but the reality is so do many, many other people in Canada, much more than engineers. So we have thousands of publications related to good health and well-being, but fractionally it's quite small because so many other disciplines contribute to these UN Sustainable Development Goals. So I don't know if it was just really to get a reflection of where engineering is contributing as a discipline of knowledge. But I think it really behooves us to think about, our strengths, and definitely we have a strength in clean and affordable energy. And this is something that we should be, showcasing to NSERC and to others, and really amplifying that and strengthening that as a strength that we have. When we think about our role globally, and I didn't show this data, but in areas like clean water, we are a global leader. We're in the top 5 in terms of some of that earlier circle analysis I showed in terms of our contribution globally to the world of water. We aren't in energy, but I think we could become a world leader. And I think it's really looking at our core competencies now and how do we position ourselves so that a decade from now, we will be a global leader in the areas that we feel Canada should be leading. And I do think energy is one of those areas.
Can I add something just on top of this, if you don't mind? To me, one of the issues is that we often don't know that our skill sets can be applied to solve problems. I'll give you one example of a colleague who is really an electrical engineer who deals with control systems. And it was only through, I think I almost call it a random interaction with somebody else, that they realized that the control system they were using for an electric drivetrain had applications in artificial organs. And this resulted almost overnight, comparatively speaking, in terms of a major individual in a healthcare setting when this person never defined their role there as a researcher as being applicable to healthcare. And I think this is one of the things that we need to really look at, is identifying the whole range of different skill sets and tools, knowledge bases that our researchers bring, and showing them that they actually can make huge impacts in a whole diverse other range of areas. So to me, I think we're just kind of seeing the tip of the iceberg of the potential of the engineering profession to contribute to solutions more broadly and to many different classes of problems.
Okay, thank you. Question that basically could be directed to any of our panelists, but I think I will direct it to Bruce first, given the trailblazing work that he and his company are doing at the global scale. And the question is how the grand challenges, are they helping to improve their ranking position of Canada against the top industrial countries? And I think it would be good to have Bruce's perspective about how does the work that he is doing globally compares to what Americans are doing or Europeans are doing on that front. And the sub question is, are there any targets or goal or plan to address this issue of basically what are we doing as a country, as a profession, engineering profession in Canada, basically to contribute to those grand challenges. So maybe Bruce, if you could go first, and then after that, maybe our other panelists can jump in.
Mm-hmm. Sure. Yeah, I would say we enjoy our middle power kind of position as being able to influence. And so in the field of, say, food waste prevention, Canada be near the top, like, say, as part of a North American food loss. It was a side agreement of NAFTA to collaborate on Commission for Environmental Cooperation, it's called. And the work that was being done in Canada was absent to a large extent from the other two North American countries as far as kind of this prevention angle. So I think we have something to say on kind of the systemic thing. Similarly, water out of Calgary, there's Cost, Center for Affordable Water and Sanitation, who's influencing like 5,000 projects around the world on kind of safe water for the developing world. And we're influencing the conversation there of how do you do it as a micro social enterprise rather than a relief model that dries up during COVID when donations stop. Instead, you're releasing the local capacity. So I think we can think about it as we have something to add and something significant to add in each of these SDGs. And it's more on the strategic, what should you do kind of thing. And so even in the crowded field of energy, you know, in our case, we don't put solar panels on our roof in Elmira. We put them on the roof of an orphanage in South Sudan because they have twice as much daylight. I get twice as much power from the same panel. And I can shut off a whole generator that they used to run their water pump. So we can do these things strategically, I think, is kind of a role that Canadians can play.
Thank you, Bruce. Kevin, Jim, or Mary, you want to step in? Okay, well, we can move to the next one, and the next one is would be directed to Jim. It relates to education. It's a very long comment that we have on the chat about how would we go about implementing a new curriculum model at the undergraduate level, basically to address some of the issues that you have identified, Jim, in your presentation about developing engineers who are complementary rather than basically copycats of one another. So the participant who asked the question is listing a number of issues that are directly related to the grand challenges in terms of adaptability, resilience, personal growth, long-term personal growth, basically exposing to practices that can be implemented in their career and their lives. So what are some of the ideas? I know that you shared some at the end of your presentation, Jim, but maybe you could expand a little bit more about specifically at the undergraduate level. What are some of the things that we could do to educate undergraduate engineers who would be better prepared to take on those grand challenges?
I hope you're going to give me a half hour for this answer. So let me there's some really interesting thoughts in here about, you know, just even the issue of mindfulness, mental health, awareness, and all that. I remember email correspondence back and forth when we were actually looking at these grand challenges initially. And I propose that one of the grand challenges is self-awareness, that we ourselves need to start to understand who we are as engineers. I would argue as part of that, that self-awareness, we also have to bring that same lens to who we are as professors. And I would argue that, I've said this in other presentations, that we've met the enemy and he is us, to use an old quote from an old comic strip, Pogo, years ago. Engineering professors have a tendency to want to add more and more material into the program until it's bursting at the seams. What we need to have is deep dialogue at the level of programs, at the level of even accreditation, at the level of institutions to decide on what are the critical learning outcomes that we need out of our programs. when you talk to students, let's say post-graduation, 3, 5, even 10 years out, often many of them will comment that they didn't find that applicable many different subjects that we taught within university. Now, I think there's an argument that we can push back on that, because some people actually do take advantage of that. And there's even value in the learning process itself to working through complex problems, rigorous tools, whatever it may be. But I think what we need to start thinking about is going back to what I refer to as a core curriculum, to kind of understand what are the key learning objectives that our people should have, but preparing them to learn rather than to just dump knowledge into their heads that they then have to regurgitate back. And so it's creating an awareness of the tool sets that are out there and creating an adaptability to those tools. So we prepare people to actually use tools that we can't even conceive of right now. That requires a really, really deep conversation about what the essentials actually are. And I would argue a self-awareness is actually part, perhaps, of that, what that core might look like. Equity, diversity, inclusiveness, I think also means taking a very deep look at who we are ourselves. So again, first conversation about it is, let's look at our curricula, let's back off, let's identify where the core is, and then let's identify what additional learning outcomes our students might wish to acquire over the course of their undergraduate education, and give them the means of doing that. And that actually means more flexibility in the program after the core. So we define the core as necessary, but not sufficient to define what an engineering undergraduate would look like. But this requires, again, deep conversations about what it is that we see as the goal. Another piece of this, though, I'll just say, and I'm going to throw it back at Bruce maybe at some point here, is I would argue that learning can never stop. It's not like you end from graduation and then go off and prepare to use those tools for the rest of your careers. Continuous education is a requirement. And so it doesn't necessarily require you to take another degree, a master's or a PhD, but there's a huge role for continuous learning. And I think that connection to what industry values as well, to make sure that we prepare our students so that they can thrive over their entire careers.
Just
for that,
jump
Jim.
in, Claude.
Yep.
We got to hold two thoughts in our head at the same time with this question. It's a great question. One is the incredible thing that is an engineering degree. We see the value of it. It's led to great problem solving. And the other thing is to really do what we're calling to do to get our engineers well positioned to solve these grand challenges. We're thinking about a rethink of engineering education, a really reimagining to do two different things. One is to get students engaged in complex problem solving. In a lot of our examples, we see what happens in our courses. The problems that students are solving are still really simple problems that they can solve with a calculator, as opposed to something that is more complex of the nature that we're talking. And the other is true interdisciplinarity, where students are working alongside students from other disciplines to gain that perspective. I think those are two core elements that we need to figure out a way to introduce, and do that in a way where we don't just add it all on, as Jim was saying in his presentation.
I might just add one other point, sorry, and then Bruce, I'll let you go.
Yeah.
I think in the short term, what we are doing is looking at ways through some of the extracurricular activities, co-curricular activities our undergraduate students are doing to engage them in these complex problems. And one thing we're talking about piloting next September is a design challenge related to the Canadian Engineering Grand Challenges that'll allow them to work with other disciplines, but also focus on a challenge in their community that's related to it. And so in the longer term, I completely agree with what Jim and Kevin said, but that could take some time. And in the shorter term, the extracurricular and co-curricular activities are ways to engage them and start to develop some of those competencies, but also to see how many of our students are so interested in these. We did a survey of the students, and clearly 93% out of the 3,000 that entered said, we want to work with other disciplines on these large, complex problems. Our students are demanding it, and we need to answer that call in terms of their own hopes and dreams for the future.
Yep. And if I could just throw in, I think Jim's onto something with kind of the core curriculum aspect versus the Swiss Army knife with 100 tools in it. Because when I look at the people we hire, we have forestry engineers, mechanical, electrical, system design, chemical. Doesn't really matter. What we're actually looking for is that style of thinking, which is kind of core of how do you think of a whole system and how if you change this part of the system, it's going to affect that part of the system. And how do you do an energy balance or water balance? You know, like how do you, some of the tools associated with that, but literally 90% of what I learned in chemical engineering, I don't use, right? And similarly, you know, mechanical, whatnot. So the capacity to learn, and I don't even rely on any formula I learned there. If I'm going to relearn whatever I'm going to use, right? And so I think you're onto something with kind of this core aspect, and that would make hiring engineers even stronger, right? If we could get better on the core where, hey, engineering is the easy part. Our tagline is engineering change, and engineering is the easy part. If you want change, you need every stakeholder at that facility to agree that you're going to change this in that way, right? That's not core engineering. You need that in that personality, and that's something that can be fostered in the curricula also, right? Is not just an idea, right? You need to bring everybody on board with that in that process. So there's some core things that could be added that would make the engineering profession much stronger, and we wouldn't need to retrain when they come in. Yeah.
Thanks for that. So we'll go back to a question that came up a little bit earlier, and it relates to research and also relates to many of the comments that were made by all of our panelists, in fact, regarding the importance of interdisciplinarity, whether it's in terms of education or research. But if we look at research more specifically, there's a very specific question about how do we go about convincing the Federal Tri-Council to fund interdisciplinary research, and more specifically to get answer, for example, to fund non-engineering research that would be, or what would be qualified as non-engineering research according to our current definition, but non-engineering research that would be conducted by engineering research investigators. So anyone has some ideas to share on that front?
Maybe I'll start, make a few comments, and I'll pass it off to my colleagues. But I think with Canada's commitment towards net zero by 2050, and this being a law now, we do have an opportunity to approach NSERC around opportunities to help us achieve those goals, and clearly showing that, you know, with those circle graphs and things, that we need all the disciplines to be able to work together on them, and maybe having a special call or special series of fundings to specifically advance some of the UN Sustainable Development Goals. And, you know, even we've identified the Canadian Engineering Grand Challenge, but what are the grand challenges for Canada as a country? I'm sure many of them will be completely connected to some of the areas that we've identified. And then, you know, making a requirement that we do need to work together in kind of a network of excellence or whatever it might be, and to provide those opportunities and funding to do that. And, you know, put some metrics down in terms of, you know, our graduate students and our undergraduate students that engage in this research, in terms of the kinds of experiences they will have that are both within their discipline, but then outside of their disciplines as well. So those are just some of my initial thoughts, but I'll pass it over to my other colleagues.
I'll jump in just for a second to say this. Too bad we didn't have a representative from the Tri-Council here to hear that call. But I think the funding agencies in Canada really want to do this. They want to find a way to support multidisciplinary work that crosses boundaries. I think we've seen attempts of the Tri-Councils to do this kind of work between SSHRC and NSERC and others, and CIHR and NSERC, to do these kinds of things. I think it's somewhat on us as well to lead the way in terms of showing the impact, as Mary mentioned, on these goals. Now, I don't want to lean too far to make it a political mandate, because because of the preference for discovery-based research. But goals such as carbon neutrality, is such a global goal that we need as a country. If we can show the funding agencies this is the way to get there, I think is a key ingredient of that. But I think they'd like to help us.
Thanks, Mary, and thanks, Kevin. There's another question, I guess, probably a thought-provoking question, also relating to innovation and regulation. So there's a question is about basically the perception that that can be either right or wrong, that innovators and regulators, and the example on regulators is the example of our professional accreditation system. Basically, that these two perspectives oftentimes are conflicting with one another. Both are clearly needed, but are there ways in which professional engineering societies can try to smooth this divide. And before inviting our panelists to comment on this, I just want to basically point out that Engineers Canada, as part of their current strategic plan, has engaged into a strategic review of the entire professional accreditation system in Canada. So both in terms of the purpose of accreditation as well as the scope. And it's the first time in more than over 50 years that our professional accreditation system has been in place that they are engaging in such a comprehensive exercise. So hopefully many of the problems or issues that we see right now with our accreditation system and will hopefully have the opportunity to be addressed within this strategic exercise. But I also ask our panelists, maybe they want to comment on this perceive or this perception that's oftentimes or sometimes innovation and regulation are maybe not aligned perfectly with one another.
I'd love to just start on this one. So I think that it's more than a perception. I think it's rightly and rightly so. I think regulation is about mitigating risk. Innovation is about taking risks, but informed risks. And so the issue for me is finding that, in a way, sweet spot that, if you want, allows the professional societies to start recognizing a different type of engineer than is classically defined through, let's say, the regulatory, the acts that are in our various provinces that define what engineering activities are. I think that we need to look at the skill sets that engineers bring, the problem-solving lens, the capacity to work within competing constraints and mobilize different tools and work in teams. We need to recognize and value that, but recognize that engineers can express their output in very different ways, not classically defined by building bridges and building buildings and power networks and transportation systems and the like. So if I would wish for one thing, it might be that our professional engineering societies might actually take a broader view of what engineering as a profession actually is, and then open the door to perhaps even different categories of engineers that might work in different spheres and be recognized as conducting engineering work. In order to do this, they have to bring not a lens of if you want, absolute risk mitigation, but risk management, just to make sure that people are qualified, competent, with the right mindset when they tackle the tough challenges that actually require us to take risks.
Thank you. Any other comments on this?
I could comment on a different aspect of regulation. So
sure.
Innovators are going to be the first people to run into the limits of building codes, bylaws, all these kinds of things. So we have a client who their only wastewater is domestic sewage, and they still don't comply with the bylaw because the bylaws were written in the 1980s when you had 20-liter toilets. So through water efficiency, you use less and you have the same amount of poo basically in the water. And so we're advocating with the regional government that, hey, as an engineer, it actually doesn't matter at the treatment plant how much water you mix it with. You still got to treat the same amount of material. This bylaw is no longer relevant in this format. We need to change this. Or similarly on the building code. The building code says you need to drain your roof within 24 hours of it raining. But it doesn't say why. So if we're going to put something in a bylaw, we should, or in a code, we should say why. Because that requirement might never be relevant again, right? Is it to make room for the next storm? You can do that with controls instead. Is it because of, whatever it is, you can address these things, but if you don't say why, you can't innovate, right? And so I guess engineers have a role in advocating for change in even regulations based on our knowledge.
Yeah, very, very true. We have a question that relates to the, I guess, the internationalization of the educational experience of our engineering students. So how basically can we better expose or increase the exposure of our engineering students to basically the international aspects of engineering? So either through taking courses abroad, contributing or participating to teams projects that are done outside of Canada as part of their engineering studies in Canada. So any thoughts on how we could basically better expose our students to what's happening outside our borders?
I'll lead in there, Claude. I saw the question in the chat. It's a great question. I think we'd probably get universal agreement here, which is hard in a room this big, this number of people, around the value of this, right? The value of international experience, the value of international perspectives on this. And I'll point to, you know, one of the obvious ways is through international exchanges of our students, be that through courses that they're taking or through co-ops and internships that they can take in international locations. Those are extremely valuable. There's barriers there in terms of our current accreditation system that we're working, hopefully, as you mentioned with the review, for changes that will make those more easier. But I think we've seen some examples during the last 2 years of COVID where we can bring people together and from you know, across the world through online platforms. And I think there's a real potential for doing this. We've done this in a couple examples where we've partnered with a group called How to Change the World, with bringing students from various backgrounds across the country together in a course, or even students from Canada and international working on these kind of grand challenges. So I think there's a real tangible way that we can do that with a very low entrance kind of barrier to get that perspective involved in our students. And that goes not only working with other students, but also with other clients and other problems, for example, that the students are trying to solve.
Thank you, Kevin.
Claude, I might just add as well, Kevin gave a great answer, but I think the other thing is if we think about, you know, the development of what I would call inclusive engineering leaders, it's critical that they have a perspective of diversity. And, you know, you can think of diversity in a 2D perspective. You have your inherent diversity, and that's your own lived experiences that you have had, but then you can acquire diversity by exchanges, going to live in another country, and understanding and seeing those perspectives of different people. And that can really enhance your ability to be a leader and more fully understand and embrace issues around equity, diversity, and inclusion and belonging. And so it is critical in terms of the development of future leaders. And I completely agree. The more diverse experiences we can give our students, the better the outcome will be in terms of their creativity, their ability to innovate, and the diversity of their own thoughts.
We have one of our participants who is very interested in finding an engineering job that supports our strategic development goals or Canadian engineering grand challenges. And I know that her post has already attracted a number of answers and suggestions from both our panelists and other participants, but I'm just interested to get the perspective, additional perspective from our panelists about what would be your advice to those individuals who are really looking forward to make a difference, to contribute to the UN strategic development goals, contribute to our Canadian engineering grand challenges, and they want to work in careers that will allow them to make a difference, a contribution. So what would be your advice to that particular individual, as well as to all those who are in the same situation?
I responded briefly to Desiree's comment in the chat, and the thing for me, so I'm a chemical engineer who did a master's and PhD in environmental engineering, and I would argue that I'm trying really hard to put myself out of business because much like I think what Bruce's is, why deal with waste? Why not work upstream to try to prevent waste from being created in the first place? And so it's actually caused me to shift very much my own approach to my research to focus less on mitigation and treatment strategies and more on approaches to actually reduce the amount of pollution or impact at the outset. If you bring that approach, even in a job search, you could look at where you can actually bring your skill set, your devotion, your values of being committed to sustainability to work in such a wider array of sectors than you may ever have thought of to start with. So you might be looking for a firm that has, let's say, Enviro in their name, which is a good thing if you can find a position like that. But just imagine all the other kinds of jobs that are out there where you can make a huge difference. You could be doing really, really deep technical work, let's say in an aerospace firm, designing, let's say, engines of airplanes. that technical work has really, really important implications. So you can do really deep technical specialization in aerospace and translate that into massive benefits if you mobilize it in the right context. So all I would say is I really, really encourage you to broaden your horizons about where you see you can mobilize your skill set, your values to maximum effect. And don't narrow it to a group of companies that might define themselves as being green.
Thanks. And we're getting close to 1:30, so we'll stop it here. And I just want, lastly, just to say on behalf of the Canadian Academy of Engineering and of the National Engineering Month, I want to thank all of those. I think at some point we had over 150 participants. So thank you very much for your attendance and active participation to this webinar on our Canadian Engineering Grand Challenges. Many thanks to Bruce, to Kevin, Jim, and Mary for your contribution as panelists. That was great to have you all in this virtual room for this very interesting panel. Also want to thank our colleagues at the CAE, Robert, Anne-Marie, and Emmanuel for helping us with the logistics of the webinar. And also thanking the Ontario Society of Professional Engineers, because OSPE is organizing our National Engineering Month this year. And lastly, a very special thank you to all our National Engineering Month partners, and you can see all their names on the slide that is on your screen right now. And there are still many things, many events are still planned for the reminder of our National Engineering Month. So hopefully you will participate to many more activities and you will enjoy them. And in closing, I can only tell you that to stay safe, stay healthy, and more importantly, stay happy. Thank you very much to all for your attendance, and a very, very good Engineering Month to all of you. Thanks.